Welcome to Career Designer 360. So today we'll be learning about cluster analysis. Cluster analysis is a part of advanced statistics and it is quite exploratory in nature and it tries to identify structures within the data. Cluster analysis is also known as segmentation analysis or taxonomy analysis. So the idea is we use the method of cluster analysis to identify different homogeneous groups of cases present in a data. We basically try to identify responses having similar pattern, and then we club these cases together in a cluster to form groups. So for cluster analysis, we can use the method of cluster analysis on more or less any type of data, may it be nominal, ordinal, scale, interval, or ratio. Further, most of the times cluster analysis is used in conjunction with or discriminant analysis or other sort of analysis. The method of cluster analysis is very essential for identifying the patterns in different fields of medicine, marketing, and education. So you guys can follow the text here and see what are the different how the cluster analysis is used in these different fields. Further, however, on a technical note, it is very important for us to identify the difference between cluster analysis and factor analysis, when to do a factor analysis and when to do a cluster analysis. See, we use factor analysis when we want to cluster variables together to represent a particular domain. Correct? When we want to cluster variables together to represent a particular domain. However, when the purpose is to identify the cases or group the cases together on the basis of responses on different variables, then the scope of cluster analysis comes in. Cluster analysis has many methods, or there are many methods of cluster analysis, such as k-mean analysis, then we have hierarchical analysis, and then we have two-step cluster analysis. So let's go through these very quickly. So k-mean cluster is a method to quickly cluster large set of data. The researcher defined the number of clusters in advance. So in k-mean cluster analysis technique, we already know the number of clusters in advance. We already input the number of clusters in advance. Okay, so it can be applied to large set of data, large chunks of data. Again, hierarchical cluster is the most common method. It generates a series of models with solution from 1 to n number of cases. So what is hierarchical cluster? In this method, each case is treated as an individual cluster initially, and then one by one all the cases are combined in a single cluster. So technically what happens, initially all the cases are considered to be a cluster in itself, and then the most similar cases are clubbed together, and thereby the process continues of clubbing together, which leads to fewer number of clusters and better understanding until there is only one cluster left. So hierarchical cluster analysis can handle nominal, ordinal, scale data. However, it is not recommended to mix the different levels of measurement. Again, the last one is two-step cluster analysis. The two-step cluster analysis identifies grouping by running pre-clustering first and then running the hierarchical method. So basically this is a combination of the two discussed technique, that is k-mean cluster and hierarchical cluster. So it initially runs a quick algorithm to identify some of the large data sets, large chunks, and then it goes to the hierarchical cluster method. In this respect, it is a combination of previous two approaches. Two-step clustering can handle scale and ordinal data in the same model, and it automatically selects the number of cluster. Okay, so since now we know what is the difference between factor analysis and cluster analysis, further we know what are the different types of cluster analysis which is present, it is important for us to also know what is the difference between cluster analysis and discriminant analysis. So when it comes to discriminant analysis, we know the groups or the clusters beforehand. Okay, so when discriminant analysis is concerned, we just try to identify, or we just try to assign a group to a particular case, whereas the groups are known from beforehand. In terms of cluster analysis, it is more exploratory in nature. We do not know the groups beforehand, rather we just explore through the data to identify patterns and cluster the cases, group the cases in different clusters. Okay, so this is the basic difference between discriminant analysis and cluster analysis. Now, how does the cluster analysis work? What is the logic behind cluster analysis? So basically, cluster analysis work on the basis of two major things, that is measure of similarity and measure of dissimilarity. So measure of similarity is nothing but correlation coefficient, or R. So what is the variation between the two cases? What is the similarity between the two cases? The similarity between the response pattern of the two cases can be identified by calculating the correlation coefficient. So it is a measure of similarity. So those cases which have more similarity between them is tended to be grouped together in a single cluster. Okay, and coming to the second part, that is measure of dissimilarity, that is Euclidean distance. Euclidean distance is an alternate of correlation coefficient which cluster analysis uses. So what it does, it calculate the geometrical distance. Calculate the geometrical distance between two cases, and then those cases which are far apart are not grouped into cluster, and those cases which are relatively closer together can be grouped together. So we have this formula here. We can see that we have the formula for calculating Euclidean distance. Okay, moving ahead. So here if you go through you can easily understand the whole thing. Let me read out for you. Creating the cluster. Once we have measured the similarity between the cases, we can think about the ways in which we can group cases based on the similarity. There are several ways to group cases based on similarity coefficient. Most of these methods work in hierarchical way. So you can see, okay, after identifying the similar cases, we have also different clustering methods which can be used to make the clusters, make the groups. Okay, we will be discussing these methods in detail further. However, let's see the data for cluster analysis and how it can be done. Okay, so here we have a data which represents the different type of sandwiches which are served by different restaurants, namely McDonald's, RB, then we have Burger King, Dairy Queen, and Sonic, and Wendy. So we have these details of the different sandwiches, different food items being sold by these restaurants, and we also have the nutritional values such as amount of calories, total fats, sodium content, calories from fat, saturated fat, trans fat, and cholesterol, and other details for each sandwich. Now what we will be trying to do, we'll be trying to run cluster analysis on this data to identify what are the different clusters, what are the different sandwiches which are going to club together on the basis of some variables. The variables may be calories or total fat, sodium, calories from fat, etc. That it depends upon us how many variables we want to take into account for the particular identification of clusters. Okay, so let's go ahead. So for running the cluster analysis, we have to go to analyze, then we have to go to classify. So you can see there are three things: two-step cluster, k-means, hierarchical. So for today's lecture will be focusing only on hierarchical cluster. Okay, so what we can do, we can select calories, total fat, sodium. So suppose let's cluster the data on the basis of these three variables. Okay, these three variables. Okay, and then what we can do is label cases by sandwiches. Now we have different boxes here, that is statistics, plots, methods, save. Let's see. In statistics you have agglomeration schedule and proximity matrix. So agglomeration schedule is basically is a table which will be there, which gives us an idea of how each factor is contributing, how each additional cluster is contributing to the data or the identification of data. Okay, so it's when we will be discussing the results interpretation, we'll be going more in details on this factor. Okay, so there is cluster membership. We can select we want a 3 cluster solution, or we want a 5 cluster solution, or we can also select a range of solution between 2 to 4 or 2 to 5, whatever we need. Now it is important for us to understand that the greater the number of clusters in a solution, the greater the problem of identifying the meaning of the cluster. So that if the number of clusters are very huge, then it is more likely that we won't be able to interpret it logically, so it won't be helping us in any way. So it's always better to keep the number of clusters around 5-6, so that we can out to 3 we can get a better idea and more number of cases can be included in it. Okay, so going further, let's take a single solution, then we can go for the range of solution later on. So we are selecting number of clusters equals to 3, and then we have plots. Let's take dendrograms, and then we have this is icircle. We don't need icircle, this is a default which may come, but we don't need. Basically a dendrogram will serve the purpose. Continue, methods. So here we can see about different cluster methods: between group linkage, within group linkage, nearest neighbor, further, centroid, median, word methods. So all these methods we'll be discussing in our text. Then we have measure. So this measure represents what type of data on which we are going to run the analysis. It represents the data. So is our data on interval scale, or is it on nominal or binary, or so on, ordinal, binary, so on. So for interval data we have these different ways to identify the differences or similarities or dissimilarities. Again, for counts, that is your ordinals, nominals, we have chi-square and phi-square measured. Then we have binary similarly. So here in this case we have an interval data, so we click squared Euclidean distance, and let's select centroid clustering. Okay, then again we have an important part here: transform values. So most of the time it happens that, suppose we can see here that calories here is somewhat like 400, 300, and it's a 3-digit numbers more or less, whereas total fats is 10, 11, 18. So the ranges differ quite high, right? The ranges is range or we can say the range is very different for different variables. So what we can do for a better analysis is that we can create we can transform these values in more like a standardized value, may it be z or may it be range from -1 to 1. So it becomes more logical to run cluster analysis on these data. Okay, so by variable continue. Okay, now we have a save option here. So this will, if we click the save option here, single solution, number of clusters 3, then we will get an additional variable on running the cluster analysis, which will tell us that a particular case which belongs to which type of cluster. Okay, so that's it. Okay, let's start and let's get results. It's taking a lot of time. Let's wait. Okay, so we have our data here. So this is case processing summary, that is 100% of the 190 cases are used, and then we have this agglomeration schedule and so on. Dendrogram. So dendrogram looks more or less like this. This is cluster membership. This shows us that each case, that is the first case, that the first RBQ is a member of first cluster. So they have identified 3 clusters, and on the basis of 3 clusters, each case is assigned to a particular cluster. Okay, so this is quite long, and this is more like a dendrogram. So what we can do, since we have a very huge data and since there is a huge dendrogram which appears here, what we can do, we can run the analysis again, and this time split the output on the basis of a restaurant. So let's try this part. So I'm going to delete the output. Okay, so we go to data, we go to split file and split file, and then we go to organize output by groups and on the basis of restaurant. Okay, so here we go. So we have just clicked and it says that sorted cases by restaurant. So now we can see in our Spss file that all the restaurants are aligned, right? So we have, first we have Arby's, then we have Burger King, then we have all the sandwiches of Chick-fil-A, and then Dairy Queen and so on. So let's delete this one. Okay, so again we are going to run the same analysis, that is analyze, then we go to classify hierarchical cluster, and we have these 3 variables on the basis of which we are going to identify the clusters. Okay, so I think we have already selected all the things. Okay, now we can do one thing, that we can change this to 2 and 4. Okay, now this will be a better okay, so let's run the analysis. Now we have the output. So we can see that output has been split on the basis of different restaurants. So we have RB here, we have Burger King, we have sticker file, then we have McDonald's, then we have Dairy Queen, Wendy's, and so on. So let's go through. It's taking some time to process. Okay. So here we have a restaurant named Wendy, right? Wendy. So let's see what are the different results. So the first part we get is restaurant equals to centroid table, which we have, and we have agglomeration schedule. So we can see this is the agglomeration schedule. We have some coefficients enlisted here. We just on double clicking the coefficient, and if we make a graph out of it, create a graph, line graph. So basically agglomeration schedule shows us on addition of each cluster what is the amount of each cluster is, how it is contributing to the understanding of the data. So we have a cluster, we have a agglomeration schedule somewhat like this, we have a graph somewhat like this. So it should however technically it shows that up to 22 clusters it is not helping mostly, and then after making 22 clusters there is a sharp rise in the grouping pattern. That means, however, this should not be the case. The case should be initially there should be a sharp rise, and then there should be a smooth slope behind. So however it may be different for different data. Here we can see we have different type of cases, for example double hamburger, single hamburger, and then there is a club cluster membership. Now remember, when we were running the analysis we selected let me show you. When we were running the analysis we selected hierarchical cluster, and in statistics range of solutions between 2 to 4. So that's why here we can see that the results have basically they have initially there were 2 clusters, 3 clusters, and 4 clusters. So it's showing us that if there are 2 clusters then the double hamburger belongs to the first cluster. If there are 3 clusters in total then the double hamburger belongs to the first, and again if there are 4 clusters then the double hamburger belongs to the first cluster. Now there may be a case where these have all the group membership is same, whether it's 2 clusters, 3 clusters, or 4 clusters. However, there may be a case where it predicts differently. Suppose for example double stack. In this case, if there are 2 clusters then this particular case belongs to the first cluster. If there are 3 clusters then this cluster belongs to the third one, and if there are 4 clusters it belongs to the fourth cluster. Okay, so that may be the case on depending upon the number of clusters we want we select. We assume on that basis the group membership will change. Further moving ahead, so this is a dendogram which we get. Dendogram is more like a family tree you can understand with. So the just like in a family tree we have closer relatives clubbed together, more together in a single branch, and the distant relative further in a different branch, and so on. So just like a family tree you can get an idea of a dendrogram. The cases clubbed together represents the cases clubs together represents closer relation between them, and then again, and you can see this is a cluster in itself, and then there is one more cluster, and then there is a cluster here. So this particular cluster, let me show you. Okay, so this particular cluster is more close to this one as compared to this cluster with this one, correct? And then we have a case which actually doesn't belong to any cluster and is a cluster in itself. So we can omit this outlier, which is basically an outlier. It's a triple hamburger, quite heavy. Okay, so technically what we can see here is Dendrograms, just like a family tree, tells us about different clusters and their relationship with each other. So in the first cluster we can see more or less all the sandwiches are low on calories, sodium, and so on the variables. So we have similar type of things like go wrap, and then again chicken wrap, then we have kids meal junior and kids meal junior. So we can see that approximately from here to here most of them are either kids meal or it's a junior cheeseburger or something like junior, something related with small size and less amount of calories, sodium and fats. So you can see a similarity of cases, right? We can see a similarity on the basis of some similarity, on the basis of the similarities in the variables. These different cases are clubbed together to form a single cluster. Similarly, we have again a different cluster here which shows different sandwiches of medium sizes, and there is a different cluster here which are mostly the heavy ones. Okay, so I hope this is clear what is the purpose of dendrogram. Let's go back to the theory part, and now let's go through the let's go point wise to each and every steps which we took in running the analysis. So what we did in SPSS, you have to go to run cluster analysis, you have to go to analyze, then you have to go to classify, and then you have to select one of these options available, either k-means, hierarchical, or two-step. These are difference which we have already discussed. Okay, the hierarchical cluster analysis follow three basic steps to give you the output. It calculates the distances between the cases, links the cluster, and choose a solution by selecting the right number of clusters. Okay, so first we have to select. So when the the box opens, so we select the variables upon which we are going to base our clusters. So we can see here that when we go to analyze, classify, hierarchical cluster, these are the variables which we have selected on the basis of which there is going to be clustering method run. Okay, then in the dialog box statistics, we can specify whether we want the output of proximity matrix, which is the distances calculated in first step of the analysis, and that is your Euclidean distance obviously, and the predicted cluster membership of the cases in our observation. Again we leave all these things default. In the dialog box we should add dendrograms, as dendrograms adds to the value, and we can visually see what are the different cases which are grouped in the cluster, and it helps us to easily understand the output. Okay, so again we have a box method, dialog box method, where we basically choose what type of measure, what type of data we have on a file on which we are going to run cluster analysis, and further we have to choose the different methods which we will be learning about. For interval data, the most common is squared Euclidean distance. It is based on the Euclidean distance between two observation, which is square root of the sum of the squared distance. Since the Euclidean distance is squared, it increases the importance of the large distances. So we all have already learned what is Euclidean distance. Now the square of the Euclidean distance is actually the squared Euclidean distance, nothing else, nothing rocket science in this. Okay, then for ordinal data we have two, that is chi-square and phi-square, and for binary we have a squared Euclidean distance, which is commonly used. So the next is we have to choose the cluster methods. So here we have let's get an idea of what is a cluster method actually is. Typically choices are between groups linkage, that gives us a distance between cluster in average distance of all points within the cluster. Nearest neighbor single linkage, distance between the cluster is the smallest distance between two data points. Furthest neighbor complete linkage, distance is the largest distance between the two data points. And Ward's method, distance is the distance of all clusters to the grand average of the sample. Okay, so the idea is single linkage works best with long chains of clusters, while complete linkage works best with the dense blobs of cluster. Okay, between groups linkage works with both types of cluster as well. It is recommended to use single linkage first, although the single linkage tends to create chains of clusters, long chains of clusters, many clusters. It helps to identify outliers. So once we have identified outliers, then we can remove them and we can run the analysis again. Okay, after excluding these outliers, we can move on to Ward's method. What is Ward's method? Ward's method uses an over f value, and the idea behind Ward method is results in clusters of more or less equal sizes and the minimum variance. So it makes sure that the cases are clubbed together such that in a way that the variances are minimum, the squared distances are minimum. And then there is a consideration of standardization. Basically the standardization is converting the data, transforming values data to a standardized ones if there are differences in the ranges of data on which we are going to run cluster analysis. So we have already seen in a particular case we already did the transformed values. Okay, so it will be appropriate, since if the ranges are quite different, like in our case calories were in 400, 300 and so on, whereas total fats were 10 gram, 18 grams. So these are the huge differences, right? Sodium is 1200 and something. So it's better to convert them in a standardized pattern so that a better form of similarity and dissimilarity can be calculated. Okay, then coming to the limitations, obviously there are limitations for any analysis which we run. The limitations are different methods of clustering usually give very different results. This occurs because the different criteria for merging clusters. It is important to think carefully about which method is the best and what you are interested in looking at. Again, with the exception of simple linkage, the results will be affected by the way in which variables were ordered. So initially when we were selecting variables here, so if we change the order of the variables, then again there will be a change in the results. The analysis is not stable when the cases are dropped. This occurs because selection of a case depends upon the similarity of one case to the cluster. Dropping one case can drastically affect the course in which the analysis progress. So the idea is that if we remove some of the cases, we can see there will be altogether change in the results output which we obtain, because the importance of each case is highly significant in cluster analysis when it tries to identify similar cases, and if there is a missing cases which was previously there in the analysis, then the analysis is going to change, the output is going to change altogether. The last one is the hierarchical nature of the analysis means early bad judgments cannot be rectified. Okay, so I think we must know what are the different methods in detail for running for clustering methods. Okay, so we have here single linkage or nearest neighbor method. This is the simplest method and is a good starting point for understanding the basic principles of how clusters are formed. Okay, so what happens is each case begins as a cluster. So each case is a cluster initially. Let me okay, so each case is a cluster. Here we have, yeah, so case A, case B, case C, each these are the cluster. And then what happens, find the two most similar cases A, B, looking at the similarity coefficient and pair the cases. So now if this is case A, this is case B, case C. Now if A and B are similar to each other, then it will form a cluster. Then again this now again it will, the system will try to find the next case to be merged with the larger cluster is one with the highest similarity with either A or B. Now what will happen is the system will try to identify from the other cases that which of the case represents or which of the case is most similar with either A or B. It can be with C, with A might be very similar, and that's why C might be clubbed with the larger chunk to form a cluster. So this is a case when it comes to single linkage or nearest neighbor. Okay, so moving ahead, we have we have complete linkage of furthest neighbor. So this is a variation of simple linkage method where known as complete linkage. Now in this case the procedure begins with we have let's convert this. We have A, we have B, we have C. So these are the different data points which can be represented, and initially each of them are cluster. Now what will happen, two cases with the most similarity will merge together to form a cluster, and now the system will try to find the next case which is most similar to this cluster, both A and B, rather than in the first case single linkage it was either A or B. In this case the system will try to find the case which is most similar to the both A and B. Correct? So this is a slight difference between complete linkage and the single linkage. Okay, moving ahead is between group linkage. Now in between group linkage we have this method is another variation of simple linkage. Again it starts similarly where we have each of the data points considered as a cluster in itself, and these two cases A and B forms the nucleus at the stage, and the average similarity with the cluster is calculated. To determine which case is added to the cluster, we compare the similarity of remaining cases to the average similarity of the case cluster. The next is added to the cluster is the one with the highest similarity of the average similarity value of the cluster. Once the third case is added, the average similarity within the cluster is recalculated. So what happens, the two most similar cases are merged and then average similarity is calculated. Now from the other data points the average similarity Now what we do is we compare the similarity of each case with the average similarity of the cluster, and the perfect match is now assigned to the cluster and it forms a bigger cluster. Again the average similarity is calculated. Again the remaining data points are the similarity of the remaining data points is compared with the average similarity of the cluster, and the process continues until there is one more similar to the value of the average here, and the process continues. Now coming to the word method. Coming to the word method, the word method, the linkage method are the word method is a different approach which is considered more complex than simple linkage method. This is one of the complex method as compared to others. The aim of word method is to join the cluster such that the variance within the cluster is minimized. So the whole idea is word method is basically based on ANOVA. So the whole idea is the variation, the sum of square is minimized so that more or less a similar type of homogeneous groups having similar number of cases are formed. Now let's see. To do this, each case begins with the aim of word method is to join cases into clusters such as the variance within the cluster is minimized. To do this, each case begins at its own cluster. Clusters are then merged in such a way to reduce the variability within a cluster. To be more precise, two clusters are merged if the merger results in minimum increase in the variance. Basically this means that each stage the average similarity of the clusters is measured. The difference between each case within the cluster and the average similarity is calculated and squared. The sum of the squared deviation is used as a measure of error within the cluster. A case is selected to enter the cluster if the case whose inclusion in the cluster produces the least increase in the error. So here what we can understand, the major important point is word method tries to decrease or minimize the variance on adding each case. So it tries to see that if I am going to add this particular case, whether my variation or the variance is going to increase or not, on which adding which case there will be a minimum increase in variance, and on identifying such cases are added in the clusters. So this is the whole logic of word method. Okay, with this we end the topic of cluster analysis hierarchical method, and in our next lecture we will be focusing on the k-mean cluster analysis. Please like, subscribe and share. Thank you.